Hi there, today I'm going to have a go at making the valve rod and fork end for the Stuart 10V, and this might give you an idea of a future project I'll be undertaking. So the valve rod is made from a piece of stainless steel bar which is 1/8 of an inch in diameter. Now at this end it needs to be machined down to a diameter of 3/32 of an inch for a length of 7/16 of an inch. Then the next 7/16 of an inch needs to be threaded 5BA, and then the following 15/16 of an inch needs to be left at 1/8 of an inch, and then the final 1/8 of an inch length needs to be threaded to 5BA, and that is where the fork end will be screwed on. So the diameter needs to be reduced down to 3/32 of an inch. So that is effectively means that 1/64 of an inch has got to come off, which equates to around about 15 thou. 15 thou is equal to 0.39 millimeters, so that's 19 graduations of the cross slide. So what I'm planning to do is to do it in 1/8 of an inch lengths to avoid any sort of flexing on the shaft. I've put a new cutter on here. It's an aluminium type cutter, but I'm hopeful it'll work on this stainless steel, and I'll cut in sort of 5 thou increments. So I'm just going to clean it up a little bit with this fine wet and dry. Just doing a test fit. Oh, that feels pretty good. Happy with that. So now I need to cut the 5BA thread 7/16 of an inch long, and 1/8 of an inch outside diameter is, I believe, perfect for 5BA. Well, that seemed to work out okay. So what I need to do now is to cut this to length. Now it needs to be 1/15/16 of an inch long. So I'll use the hacksaw in the vise just to cut it just slightly over size. Then I'll put it in the 3-jaw chuck and just face off the end to get it to the correct size. And then it's a matter of cutting a 5BA thread on the end here for 1/8 of an inch long. But I'll do all that off camera. Well, it's looking pretty good so far. Now I need to make the fork end, and I think that'll be a little bit more challenging. Okay, so the fork end is made out of this piece of brass, 1/4 inch by 1/4 inch, and it needs to be 13/32 long, 5BA thread in the end. Then the fork needs to be cut out 9/32 of an inch deep, and it also needs a 7BA clear thread, or rather a 7BA clear hole on one side, and on the other side a 7BA thread. Now, not too sure how I'm going to go about this, but first of all I'll put it in the 4-jaw chuck. I'll centre it using a gauge on these sides to make sure it's dead centred, and then I'll face this end and then I'll drill and tap 5BA for starters. Okay, so we're pretty much centred on all faces. Although I only need to tap to a depth of 1/8 of an inch, I think I'll actually drill to a depth of probably around 1/2 an inch and then just tap that. Okay, so before taking it off the four-jaw chuck, I just chamfered the end, and now I've used some loctite to stick the valve rod into the forked end. Now the overall length needs to be 2 7/32 of an inch, so I've just scribed a line at that point, and what I'll do is I'll use a hacksaw just to cut it slightly over size, then I'll place it back in the four-jaw chuck and face off the end, and I'll put another chamfer on the end. But I'll do all that off camera and then I'll get back to you. Okay, so I cut it down to size, I faced off the end, and I've now just scribed a line 1/8 of an inch from this edge here across there, and then scribed a centre line which is in fact 1/8 of an inch from the edge here. And at that point I need to drill halfway through a 7BA thread, and on the other side 7BA clear. So 7BA clear is 2.6 millimeters, and to drill for the thread it's 2.1 millimeters. So what I'll do is I'll drill right through with 2.1 millimeter drill bit, then I'll drill halfway through again with a 2.6 millimeter drill bit, and then I'll tap through to the other side. Okay, so I think it's quite important that this hole is drilled perpendicular to the valve rod. So just putting this on a set of parallels probably isn't going to be wholly accurate. Now I had a thought about using this Stephenson's collet block and holding the shaft in that and then holding that in the vise, but unfortunately that's about 3.2 millimeters in diameter, and my 4mm holder barely grips it, so I've had to do away with that idea. So I've put a gauge on here, and it's pretty much within 1 thou, so I'm happy that the rod is level, so I'll proceed to drill and tap this hole. So I've already drilled right through with a 2.1 millimeter drill bit, So now I need to drill halfway through with this 2.6mm drill bit. So that's 0.125 of an inch. And now I need to tap the other side. Okay, so now for some maths. We need to mill a piece out here 3mm wide, or 1/8 of an inch, and we've got to mill out up to a point which is 9/32 of an inch. 9/32 of an inch is 0.28125. Multiply that by 25.4 gives us 7.14mm. So I put the edge finder on here and found the edge, and I've put a 3mm drill bit in here. So 3mm drill bit, if you divide that by 2, that's 1.5. So if we take 1.5 off 7.14, that gives us 5.64. So I've moved the table that way 5.64mm. And when I drill with this 3mm drill bit, that should define the end point. So I'm now going to put a 3mm end mill on, and I'll mill out from the edge. So I'm going to mill 1/10 out at a time. Well, that seemed to work out okay. Very happy with the result so far. I used some little hand files just to tidy the fork up, but it looks okay. My hand files are ancient, they're with my father's, so if anybody's any suggestions on where I can get a nice good set from, I'd really appreciate it. And I made that off camera. So all I need to do now is to make a couple of gland nuts, drill and thread the inlet and exhaust port, and then hopefully we might be able to give it a bit of a trial run on air. So in terms of pipe fittings, unions, etc., I originally thought about going for 5/32 of an inch piping, and using these unions that are 1/4 by 40 TPI. But in hindsight, having looked at my engine, I've decided to use 1/8 of an inch piping, which I used on the S50 engine. So that's using these unions here, which are 3/16 of an inch by 40 ME thread. So that's what I'm going to be going with. So for the inlet, I'm going to drill a hole and tap it in there, and for the outlet I shall drill and tap a hole in the side of the cylinder there. So for a 3/16 by 40 ME thread, I need to drill to a diameter of 4.2mm. What I'll do first of all is I'll drill to 3mm, and then 4.2, and then tap. Okay, so for the exhaust outlet I'm going to drill using this 2.4mm drill bit right through into the exhaust port. Now that I reckon is going to be about 10mm, so I should see it break through just where that sort of recess is in the vise. Once I've done that, I'll then open it up to 4.2mm, but I won't drill right through. I'll drill it to a depth to enable me to tap this 3/16 by 40 thread. I think it should be there. I can't see anything breaking through at the moment. Let's get a piece of wire. Yeah, that looks good. Well, the length of this thread on this union is quite long, and I don't fancy trying to tap that amount of thread in there. So what I'm going to do is I'll drill to a depth of 6mm and tap as much thread as I can, and then I might have to just modify this union. But anyway, that's the plan. Well, it seemed to go to a reasonable depth. I think that'll be okay. So the piston gland nut is made out of a piece of 7/8 of an inch brass bar, and it needs to be turned down to a diameter of 1/2 inch, and then this end here threaded to 5/16 by 26 TPI, the overall length being 3/8 of an inch, this length here being 1/8 of an inch, so the thread will be just under to 1/4 of an inch, and it needs to be drilled and reamed to a diameter of 5/32 of an inch. So my plan first of all will be to turn a length down to 1/2 inch in diameter. So I'll probably aim to cut a length just over 1/2 inch. So that's the large diameter turned down. So what I've decided to do now is to drill and ream to 5/32 in diameter. So for the reamer, I'm going to use a 3.7mm drill, and I'll drill right through and ream right through, but I'll do all that off camera. So the reaming went okay, so what I need to do now is to turn this down to 5/16 of an inch in diameter for a length of 1/4 of an inch, and then I just need to cut a thread 5/16 by 26 TPI, but I'll do all that off camera. Well, the piston rod gland nut worked out okay. I just need to finish it off by putting some little slots in it. I think that's how you fix it in. But anyway, the valve rod gland nut is exactly the same process really, and you machine it out of some 2BA hex brass. So that it's a 1/4 inch by 32 thread, and it's 11/32 of an inch long. The head is an 1/8 of an inch deep, and the hole through it is reamed to an 1/8 of an inch. But I'll do all that off camera. Well, that has worked out okay as well. So that's all the machining done. So what I'm going to do is I'm going to give the engine a quick run on air if I can, but I'm going to do it without the gland nuts installed, because to install them I need to sort of disassemble it, and I don't really want to do that at this moment in time. So let's see how it goes. Well, I've just thrown this little engine together. I've put some gaskets on the valve chest, but I haven't put any gaskets on the cylinder covers, and there's no gland nuts or gland packing, so it's it'll probably leak a lot of air. But anyway, we'll give it a try. Hey, that looks good. I think the timing probably needs refining, but we can look at all of that when I paint it and build it properly. But I'm very happy with that. Well, it sounds like spring has sprung at last, which is fantastic. And I've nearly got my garage back. The building work's nearly finished, which is really good. And that little engine seems to run okay. So things are really looking positive at the moment. In my next video, it'll be the final video of the series of the 10V build. And I'll look to paint it and do a final build. Now, paint wise, I was thinking about painting it maroon as opposed to the standard Stuart green and black, so I don't know whether anybody's any sort of views on that. And also I'd really appreciate it if anybody's any thoughts on a good set of miniature files, because I think I could do with some. But anyway, I hope you like the little engine so far, and hope to see you later.